Hello, this is my presentation on SARS coronavirus 2 testing by Jacob Hoffman. Background on SARS coronavirus 2. It originated in Wuhan, Hubei province, China, with relation to the seafood market. A virus is defined as an infective agent that typically consists of a nucleic acid molecule and a protein coat. It is too small to be seen by light microscopy and is able to multiply only within the living cells of a host. It is a single-stranded RNA virus from the family Coronaviridae, and SARS stands for Severe Acute Respiratory Syndrome Coronavirus 2. It started out as pneumonia cases from a wholesale food market in Wuhan. The first cases were in late December 2019, and by February 27th, 2020, there were 78,000 confirmed cases worldwide. It is believed to be transmitted from a type of bat to a certain live animal that was sold at the market. There are 1.23 million confirmed cases and 71,135 deaths in the USA as of May 5th, 2020. And there are 5,458 and 137 deaths in the state of Kansas, and 513 cases and 45 deaths in Johnson County as of May 5th. The types of testing for SARS coronavirus 2, the polymerase chain reaction, or a PCR test, is for detecting the presence of an antigen or viral RNA, which is present before antibodies or symptoms occur. It can detect the virus from early on. And then the reverse transcription polymerase chain reaction, or the RT-PCR test, is detection of a nucleic acid present in respiratory specimens collected from individuals suspected of coronavirus. RT-PCR tests are used for SARS coronavirus 2 because they test for the coronavirus RNA, which is the agent detected for COVID-19. Testing positive does not necessarily mean positive with COVID-19. It doesn't rule out the bacterial or co-infections with any other viruses. But as of right now, with the symptoms, it's safe to assume a positive means positive for coronavirus 19. ELISA testing for coronavirus is the antibodies bind to their respective antigens and complexes are cleared from the body by the immune system. The antibody is specific to that antigen and will only bind to any other and will not bind to any other antigen. The technique is an antigen is added to the wells of the strip and incubated. The primary antibody solution is added to the wells and binds to the antigen. The secondary antibody is added and it binds to the primary antibody. A color-producing enzyme is added, and if the wells turn blue, the test is positive, and if it is colorless, the test is negative. A positive result just means that there's the presence of IgG antibodies, which could mean you already had coronavirus or have a similar bacterial or co-infection. My hypothesis for the scenario is if 6 friends go to a barbecue, then Moira, David, Patrick, and Roland will contract COVID-19 because all of them tested positive for the ELISA test and for the presence of antibodies using a titer test. The results of electrophoresis of RT-PCR, it is shown that this is the positive and that's negative. So it shows that Moira, Johnny, and Roland all tested positive for the presence of coronavirus RNA. The results for the ELISA test, that is a positive and that's negative. So it shows that Moira, David, Patrick, and Roland test positive for the presence of IgG antibodies. And then these are the results of the titer test. The relationship between the 6 test subjects and the average amount of antibodies present taken from 3 samples. Moira had 29 antibodies, Johnny had 0.17, David and Patrick both had 13.67, and Alexis had 0.67, and Roland had 35.67 antibodies. How to make a graph with standard deviation bars. I'm going to click ahead as I just enter in the information right now. And here we're finding the average of the 3 antibody samples. And now we're finding the standard deviation of the 3 samples. Now we're making a column graph. And now we're adding the standard deviation bars, or the error bars. Okay. And then in conclusion, Moira and Roland have a current SAR coronavirus 2 infection because they both tested positive for the RT-PCR test, ELISA test, and a titer test, which means they have the presence of both an antigen and an antibody. David and Patrick had a previous SARS coronavirus 2 infection, but are not currently infected because they do not have any antigens present, but they have the SARS coronavirus 2 antibodies. Johnny and Alexis did not have SARS coronavirus 2. Johnny most likely had a similar illness, such as the flu, and the RT PCR test gave off a false positive. And Alexa was lucky and did not contract anything. And then we're excited.